welcome back to the Connected World podcast. It's me, Steve Wilkinson, here again with Mike Taylor, our Asset Reliability Lead. We're continuing our mini-series on condition monitoring, and this time we're going to talk more, Mike, about a case study. So how does, we'll take people through the journey of a customer, how it looks from kind of start to finish, I guess, what they could expect if they were implementing a condition monitoring system and the kind of benefits that they see. So for the client we're going to go through, tell us a bit about them. I know we can't name them.
Okay. So their journey as a result of condition monitoring, they had already carried out their criticality assessment internally. They already knew what assets they wanted to deploy condition monitoring solution on.
Yeah.
They're in the healthcare, pharma industry, various different types of applications, assets, agitators, homogenizers, pumps, servo drives, etc. So they've already identified the return of investment. They already were carrying out with a third party doing or completing periodic checks on these assets, and believed it would be more beneficial for them to implement online condition monitoring solution, utilising vibration sensor technology.
Yes. So for people who haven't seen the earlier podcasts, the criticality assessment, I think, is where you recommend people start. Is that right?
Yeah, it's integral to it, to the solution or to a condition monitoring program. Far too many times now we see organizations just out there deploying sensors, connecting to different devices, and they're recording data just for the sake of recording data.
Yeah.
And they're not doing anything specific with that data. Okay. So it's a case of identifying the right assets. What rewards will they receive as a result of deployment of a condition monitoring solution on those correct assets?
Okay. So the client we're talking about, then they've been through that part of the process. They've identified this equipment. Where do they go from there? What was the next step for them? Okay,
so they had completed their due diligence and identified the organisation that they wanted to use for the deployment. We had promoted, along with others, our solution. They thought our solution provided the requirements what they were after and hit the right mark for them. We engaged with them. We carried out a feasibility study with them. The feasibility study was to identify how many gateways they would need in their environment. Okay, and the coverage.
So remind me the purpose of the gateways.
Okay, so the gateways are integral part of the solution. They're the mechanism and the communication device from the sensors.
Right.
Okay. So the various vibration sensor solutions will have a different range. We've got to take into account the environmental logistic issues with regards to likes of firewalls, machinery, stud walls. They all have an impact with the deployment of sensors.
Yeah. Okay.
So you need to make sure that wherever you're deploying the sensor, you've got good enough coverage for signal strength for the communication to the gateway.
Yeah.
And then the gateway is that integral part that pushes the data up to the cloud.
Okay. So you do this kind of feasibility study, I guess it's a kind of on-site activity, site survey?
Yeah, pretty much. It's just an assessment.
Yeah.
It's all, again, non-intrusive. The assessment can be carried out during normal operation conditions. So there's no downtime, no outage required for this.
Yeah. Okay. And so that all goes to plan, and I guess you have an idea of the number of gateways, where they're going to go, where the sensors are going to go. Where do they go from there?
So on this specific journey, we identified that the requirements was for 3 gateways. Okay. the gateways were to be deployed in an IP67 stainless steel rated enclosure.
Okay.
Okay. We identified where these needed to be located. The specific company in question, they carried out the installation of the stainless steel enclosures. So they provided the means of power supply. The power supply can be 110, 240.
Yeah.
If the customer already has an existing cabinet that's fit for purpose, then the gateways are just run by 24 volts.
Right,
Okay.
Yeah.
So, and then you can quite easily run an external antenna, a cellular antenna, and a Bluetooth antenna.
Okay. And the sensors themselves powered by battery, right?
They are powered by battery. So, the recommended battery life is anything between 4 to 5 years. They're a replaceable battery.
Okay.
Okay. The many sensor solutions there are disposable.
Yeah.
But the ones that we prefer to use are replaceable. When I say the battery life is anything between 4 to 5 years, that is based on one reading per day.
Right.
Okay. Now we've got to remember what we alluded to in other discussions is that previously, if you're doing periodic checks, we're only taking one reading per month.
Yeah.
Okay, but we're taking one reading per day, which is a huge improvement with regards to one per month.
Okay, excellent. And so you can replace those batteries, keep the same sensor.
Yeah.
Is that an easy job? Can an end user do that themselves?
Yeah, very much so.
Okay.
So we can, for this application, ITI, us as an organisation, carried out the installation of the sensors on their behalf.
Yeah.
Okay. We'd identified the assets. ITI attended site. We did the installation of a glue stud. Okay. So effectively, we mount a glue stud on a specific location on the asset, nearest to a specific bearing journal, because that's the most valuable point to get any kind of signal data from maybe a defect bearing. Let the glue stud set for a period of time and then mount the sensors accordingly. The sensors are 3-axis because so we can record in horizontal, vertical, and axial planes.
Yeah.
And that's as a result, vibration will move in its weakest direction.
Okay.
Okay.
And so now we've got sensors on the assets. We've got gateways installed with power. Those gateways, are they all indoors? How does that?
No. So for the environment that we're looking at here, there is one. They have a tank farm. So the tank farm is outside. Again, with it being sufficient IP rated, no issues there at all. The other two areas of the site were both indoors. One presented a bit of a challenge, and that was as a result of cellular connection.
Right.
However, we overcome that quite easily, and that was just as a result of, with the support of the company, we ran an external cellular antenna on an external wall, and that was as a result that the assets, the machinery, was pretty much in a basement in a dead zone.
Okay. Yeah. And so the gateways then talk cellular to a cloud, I guess.
Yep.
Okay. So from the client's point of view, then what happens next once they're up and running?
Okay. So once the sensors are connected, the gateway's there. We've carried out the feasibility study. Part of the feasibility study, we took the machine details, asset information, kilowatt sizes, frame sizes of the motors, all the basic requirements for a condition monitoring solution. They were all added to the database for those specific assets. So you've got a unique serial number on a vibration sensor. That unique serial number needs to be associated to the specific location on that asset.
Right.
Whether it be a motor drive end, sensor 1, 2, 3, 4 is to pump A, motor drive end. Okay.
Yeah. And so they're getting data into like a cloud application that they can log into then?
Yeah.
So they they log into that, what kind of things are they seeing and what are they doing with that information?
Okay, so from the outset of on the deployment, we discussed there previously, usually set the sampling period for once per day. But from the outset and the deployment of the solution, we have the ability remotely to configure the vibration sensors and they can collect data every 30 seconds if needed.
Right.
Every 30 seconds, you've got to appreciate it's going to saturate the battery. Okay. So what we do is we start collecting readings every hour and we start to evaluate the machine's behavior over time. And so we're kind of, from the outset, we're working with the client because we need to get an understanding of the machine's behavior when it's in operation, when it's not running, or the certain process conditions, because we may start to see events in the vibration data that don't kind of correlate to anything specific. So we need to work closely with the customer. And this is integral to the deployment of the solution, because it's not just a case of saying to the customer, there you go, and walk away. They do need guidance and support with the implementation.
I guess that's similar to a lot of what we do with technology. The technology is just the tool, isn't it? It's not the solution at the end of the day. It's what you do with it and the support that you get from people like yourself that have the expertise. So how did that develop then? What did they discover that they didn't already know?
Okay, so from the outset on the deployment, we were, I wouldn't say fortunate for us, but not so fortunate for them. But initially on the tank farm, we identified a specific. We were seeing instances on this pump where there was excessive vibration levels. We engaged with them, said, these are the time stamps where we were seeing specific process related or high vibration events that could be a result of process related. They took the opportunity to carry out the investigation or look further into their SCADA system to see whether there was any kind of correlation. However, we were fortunate enough, not just are we taking an overall vibration reading, but we're also supporting them with the analytics. Okay, so the analytics provide us more meaningful information to identify the specific fault.
Right, okay.
So we knew the running speed. Within the data, we were seeing specific frequencies, amplitudes at specific frequencies, which was indicative of cavitation issues on the pump.
Okay.
Okay.
And so you can actually, from just looking at the data, you can almost diagnose the type of issue that's going on as well.
Yeah, very much so.
That's clever.
And that's whether that would be an imbalance condition, a misalignment condition, a bearing defect, lubrication deficiency.
Yeah.
The failure modes, there's probably 5 most common failure modes in vibration.
Were you right?
Yes.
So what did they do?
Okay, so they took an opportunity during an outage.
Yeah.
Okay, to inspect the impeller, the pump impeller.
Right.
And they identified specific wear on the impeller. And they also identified, as a result of their process conditions, that there was times when the pump was running dry.
Right.
As well. Or not specifically dry, but reduced flow, which was causing the cavitation.
I see.
In the pump. Cavitation is pretty much air pockets.
Right, okay.
In the voids of the impellers.
And what's the result of that? Does that cause wear or?
Yeah, it causes wear over time. Inefficiencies of the pump.
Yeah, okay. So what did they do? Did they?
Yeah, so they identified downtime weekend was the opportunity for them to replace the pump. Carried out the installation, informed us accordingly. And then when they were back in operation the following week, there was a significant improvement in the vibration levels, and to the point they put certain conditions in their process to eliminate them running with limited throughput.
Right, okay. So there's kind of 2 things they solved there as well. And so in terms of actual business benefit to them then, what was the outcome?
Okay, so for this specific pump, we only had one vibration sensor. mounted on the drive end bearing because it was a close coupled pump. Within this specific area, there was one gateway that supports 6 pumps. So there's a set cost on their investment.
Yeah.
However, with working with the company, we identified that the ROI saving was in the region of 15 grand.
Right.
Okay. It's just
One
straight
issue.
off from that one issue.
Right.
And that was as a result of potential unplanned downtime and the replacement of the asset as well.
Yeah.
So when you kind of look at the associated cost for that specific area, 6 sensors, X amount of pumps, it paid off for itself automatically within 6 months.
Yeah. Wow.
That was
fantastic.
But again, the impact to their downtime, the possible impact to their downtime, because they're in a clean environment.
Right.
Okay. Anyone that goes in that specific area needs to be dressed accordingly.
Yeah.
You can't just kind of go in and out.
Yeah.
So being able to plan the job in accordingly for the replacement was a huge benefit for them.
Yeah, and I've been in similar environments, and like downtime in those areas can result in you kind of scrapping a whole job because depending how the machine fails, it can be a quality issue as well as a
and it's not just maybe one batch; it's all the associated products that are down that line as well.
Yeah.
Within year one, they've seen the return of investment to the point now where they want to invest in more sensor solutions across other of their applications and assets on site.
Yeah, I was going to ask because this was obviously the start of their journey, if you like.
Yeah.
So what does the future look like for them? What are their plans with it now they've seen that buy-in?
So the next plans for them, they're in the process now of completing further criticality assessments. We've provided support with them on the next journey of their criticality assessment to identify on what is the best condition monitoring solution for those specific assets. We keep alluding to the vibration sensors where some assets aren't fit for purpose for vibration. So we have to identify alternative methods.
Brilliant. So they're looking to expand and carry on with that solution. Brilliant. So great to hear they're wanting to expand that and take it further. Thanks again for your time, Mike. And thank you all for listening.
Thank you.